Last week we discussed up to the SI units of basic quantities, that's fundamental SI units and the supplementary SI units. Up to that point we discussed. So today we are going to discuss about that SI units relevant to the derived physical quantities. Some special names are given in SI unit system. So let's see what other names and how that units and how that units we obtain, right? In basic units also you can write these all, and then we discuss some rules and regulations we use in SI unit system, uh, and there are some multiples and submultiples. So and the special names are given for that also, and then go to the dimensional analysis. Okay, then write the SI units of some derived physical quantities. Write the topic as SI units of some derived physical quantities. SI units of some derived physical quantities. You need to remember some of those. But in future, with the different lessons, they always we use these terms. Then you can remember this all because your exam is after 2 years. So then you know everything. But initially, I mean, given this all, that's relevant to your syllabus only. Syllabus එකේ තියෙනවට දාලා quantities වල units තමයි දෙන්නේ. හරි. අනිත් ඒවා ඒ එහා ගිය තව units තියෙනවා. So in the relevant lessons, you can study about those. Okay. And also there are some special definitions for these derived physical sorry, that's fundamental units. ඒවට තියෙනවා මේ special names. So SI units of derived physical quantities, we call those, within bracket you write the derived SI units. Derived SI units. Derived SI units. So definitions, you don't need to remember those definitions. As example, I can say that if someone asks, so what is 1 second? How we can define the 1 second? The 1 second is the time required for 9192770 and 631773. This much of oscillations for period of radiation due to the transfer between two micro levels in ground state of cesium-133 ion atom. As example is cesium-133 means it is a radioisotope. In this radioisotope, they emit radiations, right? This much of radiation emit කරන්න යන time interval එකට අපි කියනවා. ඒවා radiation emit කරන්නේ මේක තියෙනවා මේ ඔයගොල්ලෝ අහලා තියෙන already know that the energy levels කියලා. Electron transitions in energy levels. In between these energy levels, electrons are transition. When the electron transition, so then they release the radiation as energy, right? In that case, so this much of radiations are emitted during the time in 1 second. 1 second කියලා කියන්නේ මෙන්න මෙච්චර radiations එකක් emit කරන්න යන time. That is a real definition because the atomic clock, using the atomic clock, you can measure this very accurate. So එක radiation එකක් පිට කරන්න යන time එක මේකෙන් මේ ප්‍රමාණයෙන් එකක්. මේක 1 over this one. ඒ කියන්නේ atomic clock එකක්. If you use the atomic clock, you can measure the time which corresponding to 1 over this value. Right? ඒවා ඉතින් මතක තියාගන්න ඕනේ. It's very difficult. හරිද? මතක තියාගන්න වෙන්නේ. You can physics වලදී අහන්නේ මතක තියෙන ඒවාට වඩා analyze කරලා ගන්න දේවල් ගැන. එහෙනම් අපි you don't need to worry about it. The definitions I will give you with the tutorial. Physically then මම tutor එක physically කරත් තමයි දෙන්නේ නේ. බෙහෙම නැති වුණොත් මම PDF කරලා හරි ඒවා නම් බලමු. මේ යන රටේ තත්ත්වයත් එක්ක තෙල් නෑ මං හිතන්නේ. තව සති දෙක තුනක් යනවා. තෙල් આવොත් තමයි දැන් තියෙන්නේ මං තෙල් දැන් වාහන වල ගහගෙන තිබ්බ තෙල් වල තමයි මිනිස්සු යන්නේ. පාරවල වලත් වාහන නෑනේ වැඩි ඉස්සරවල. අපි මේක හැමෝම දැන් මේක න under that right there. Under this one we can write something. Write the units which can be obtained using basic units, basic or fundamental units which can be obtained using basic units or fundamental units. Within bracket write the fundamental. Basic units are called derived SI units. Are called derived SI units. Are called derived physical quantity. So SI units of a physical or 5 units of a derived physical quantity can be obtained by using the definition of that physical quantity. Definition of that physical quantity. All right. If you have any questions, you can put it on the Zoom chat. You can switch on the mic and ask. Mic and camera on. And also you can put the message to the WhatsApp. Any method, right? Any questions you have, come up and ask. You can ask a question or any time, right? මෙතන දැන් කලින් අද අලුතෙන් ආපහු ඉන්නවද අද සම්බන්ධ වෙච්ච අය? එහෙම ඉන්නවා නම් කලින් ඒවා කලින් සතියේක මිස් වුණා නම් you let me know, then I will කොහොමත් මම ටියුටෝරියල් එක දෙනවා, තියරි ටියුටර් එකක් දෙනවා. මොන හරි පැහැදිලි ගණක් තිබ්බොත් you can ask and I will guide you. මුල ඒවා නම් එච්චරම වරේ අන්තිම අග ඒක second lesson එකෙන් පස්සේ තමයි ටිකක් සතියක් හරි මිස් වුණාම ඊළඟ සතියේනකොට තේරෙන්නේ. ඒ සතිය කරපු ඒ වගේ වෙන්නේ. සාමාන්‍යයෙන් first lesson එකේදී you can read it and understand. මේ ගොඩක් තියෙන මතක තියාගන්න දේවල්. හින්දා. Okay, then we write these derived units. There are some rules you need to apply when you write these SI units. Units දෙකකට වඩා වැඩියෙන් use වෙන තැනකදී you need to place a space in between this. Right? As example, if you write that unit of density is kilograms per cubic meter, so there should be the gap between these two letters. Right? Two units gap එකක් තියෙනවා. Don't put the dot or any other one like this. You need to get this a rule. But මෙහෙම කඩෝල ලියන්න එපා. And also if special names are also given for the units, SI units, right? As example, the unit of force is kilogram meters per square second. So we call this a Newton. Right. So we have the problem Newton කියලා. If we use the name of a person as a unit, it should be the first letter of his name in capital English. It's another rule. I will give this rule after the writing this all, right? So first you write this as a table. So first column either quantity. Let's write quantity, and this column is quantity. Syllabus this is the definition. Definition of survey, and the other last column is SI unit. SI unit. First you make a table like ගොඩක් පල්ලෙහාට ලියන්න තියෙනවා. ටිකක් දිගට යන්න ගන්න. හරි. ගොඩක් කියන්නේ මේ ඔක්කොම වාගේ තියෙනවා ටික ලියන්න. ඒක අපිට මැද කොලම් එකේ තමයි ඩෙෆිනිෂන් එක කියන්නේ ඒකට අදාළ ඉක්වේෂන් එක මොකක්ද කියලා දෙන්නේ. So you can derive this SI unit using the base units. ඒක පාවිච්චි කරලා පුළුවන්. බලන්න derive කරගන්න. There's some derived units without special names. Some derived units have the special names. So මම ඒව වෙනම categorize කරලා තියෙනවා. හරි. මේක මෙහෙම දාලා this first. මේක අර පොඩි. මේක උඩින් හරි කවන්න. Write this as a derived units without special names. සලාම අපි ඒ ටික බලමු. You can write in first quantity this area. You know that the definition is the length multiplied by the width. Width or breadth. Someone can say it's a breadth also. Length and breadth. So it says SI unit is the length and breadth, both are the length, right? Length, meter, that is square meter. SI unit is square meter, that is SI unit. ඔයගොල්ලෝ syllabus එක සම්පූර්ණයෙන් හදලා තියෙන SI units. Because Sri Lanka is the first country who come faster to this SI unit system. We had when they introduced this SI unit system in the world, so this Sri Lanka rapidly adapt to our education system, this SI unit system. Right. So then the second one is volume. Volume. Second is volume. The volume is the length, breadth, and the height. Then breadth into height. That is cubic meter because length multiplied by twice. Third one is the velocity. Velocity. Velocity we define in our second unit, but here I'm writing it's a displacement divided by the time. Displacement over time. That is meters per second. Fourth one is the acceleration. Acceleration. Is the velocity change or difference in velocity divided by the time. Difference in velocity, that velocity difference is also measured in meters per second. It's divided by again sine 1 second. So this is meters per second and it's also divided by s, so that is also come up in history meters per square second. That's meters per square second. Fifth one, the density. Density is measured as a mass divided by the volume. Mass is measured in kilogram and the volume measured in cubic meter. So kilogram divided by m cube, that's kg divided by m cube. So it's comes up. So then this kilograms per cubic meter. Kilograms per cubic meter. That is the density. And in the sixth one is momentum. Momentum is defined as a mass into the velocity. Mass into the velocity. The mass is in kilogram. Velocity is meters per second. That's a kg ms minus 1. Okay. These 6 units, they have no special names. These are writing with the help of the base units. Base units are in defined color. No special units are there. All right. Just to write this 6. And if you finish the writing, you can raise your hand. Okay, hand raise button. So then I know that you finish off. So then I can go next, right? A table එක ඔතනින් close කරන්න. ඊට අනිත් ඒවා අපි special names තියෙන ඒවා වෙන table එකකින්. So you pass the table from this point and then because we need to write the other units with their special name and also what is the base units of them. ඒ ඔක්කොමත් එක්ක ලියන්න ඕනේ. ඒකට ඒකේ අපි ටිකක් columns ගන්න වැඩි කරන්න වෙනවා. After that, you can write in several SI units with special names are given below. Several SI units with special names are given below. Special names එක අපි එක ලියා ගමු. Then make a table. I will erase this one. And draw the another. Another table. Actually, we need to draw 6 columns. First is quantity. What is a quantity? It's a small column. Need to write the name only. And next is the special names of units. Special names of unit. Right. Name of units. Come here as examples, Newton, Pascal, like this special name. Right? And the symbol. Like body. So then the definition, that's using expression. Definition using expression. It's the equation. Therefore, the variance. And then this is divided into two. Other SI units and base units. This column, the other SI unit. Last column is the base units. Okay, so basic units. Basic units. Okay, you can do the table like this. There are a lot. All right. Basically, we need to write this, all right? First, as I mentioned you, the name of the unit you need to write with simple letters only. And also the unit symbol, the first letter of the personal name, you need to write as in English capital. Name ekak nam vitara. If it's not the name, you need to write in symbol. And also make a space between two units when you write the combined unit. Combined unit ekak තියෙනවා. If there are more than two basic units, you need to keep the space between any two, right? Okay, then we'll write the force. Special name of this unit is Newton. And symbol is capital N. The definition is Newton, that's the force is defined as mass into acceleration. That is mass into acceleration. The other SI units is same as Newton. We don't need to write it. And base unit is kilogram meter per second. Kilogram meter per second. So it's a pressure. Pascal is the special name of the unit. That is PA. In here we need to second letter also we use as PA. Pascal. So its definition is the force divided by the area. Also, so another SI unit is there because that's we can write force is in Newton, area is square meter. So we can write it as a Newton per square meter. Okay, you try to write the base units, right? with this definition. You know the force is this one, and then you try to write this one. I'll fill it later. ඒක ඔයාලා කරවන්න. හරි. දැන් අපි අදම කරනවා. ඔයගොල්ලෝ පුරවන්න. So මෙතනට එනකන් ඉවර වෙసి මම ඒ ටික ඔයාලටත් වැඩක් තියෙනවා. 1 2 third one. Right, it's a work. Smart special names for this is joule. So the capital G. Work is defined force multiplied by the displacement. Force into displacement. නැත්නම් හරි මොනවා හරි ප්‍රශ්න තිබොත් කියන්න හරි. And also write the other signs as Newton meter. Energy. Same as the work. Definition is same as this, but we call it as ability to do work. Ability to do work. So it's also Newton meter we can write. One you can write. Got power. So it's what? W. That is work divided by the time. Work divided by time. So other unit is this joules per second. Six. Frequency. Special name for that is hertz. Hertz. It's it. So it is number of vibrations divided by the time. Divided by the time. So other unit is that is per second. Actually, this sun is the base unit also. මේකක් නෑ other කියන එකක් ඕනේ නැහැ. Base unit එක. 7. Guidance. Electrical charge. Electrical charge. Especially Coulomb. Capital C. This can be defined as a current into time. Current into time. No special units, and in other unit system we can write it as current measured in ampere, time measured in T. So ampere second carry and ampere second. The units theory drama Distance to Eliana, it's still going to complete can send mama to come complete color. The 8th one, electric potential. Electric potential. So it's measured in volts, volt, and it's capital V. So its definition is the work divided by the charge. So we call it work done per unit charge. And its special units are also there. The work is measured in joules. The charge is in coulomb, joules per coulomb. Base units you can write. The 9th one, that's electrical resistance. Electrical resistance, and its SI units ohm. The Greek letter omega we use. It's omega. That's potential. This electric potential divided by the current. Definition. And the special units you can write in the volts per ampere. Volts per ampere, correct. Electrical capacitance. Measured in farad. If we use the farad, so it's defined as charge divided by the potential. Charge divided by the potential. So it's coulombs per volt. Okay, first you write after this. Then I will compile this. I don't say. So first you write and then let me know. Okay, we fill this line. The pressure. This force is 1 divided by area. So if you divide by square meter, then 1 meter cancel. So that's a denominator, the 1 meter is remain. So then it's come up. So then you can write it kilogram per meter per square. Okay, small mistake got there. This is kg ms minus 2, not minus 1, right? The minus 2 in minus 1 is it's related to the momentum. But in force, it is kg ms minus 2. This acceleration is ms minus 2 kilogram. So then it is kg m minus s minus 2. Then. Maybe then we units ලියලා ඔයගොල්ලෝ දැන් නැත්නම් මොනවා හරි question එකදී ගන්න දුන්න definition එක ඕනම එකක් කියන්න පුළුවන් questions we can give the questions if we given artificial questions we can give it's two terms like this. So the IBS units are there. So then the definition is this one. What is the units of that quantity here? So we have a definition. The force is this way. You divide it by the square meter. So you can get this. Work also force displacement. This you need to multiply by the unit of displacement, that is meter. So then it is kilogram square meter per square second. And energy, same. Work and energy has the same units. And power, you need to divide this by another second. So then it's s minus 3. So kg m square s minus 3. And these two, okay. Electric potential is joules. The joule you can write in this way kg m square s minus 2 and c minus 1. So, but c is not the, you need to remember that one. C is not the SI units, right? See, the coulomb is not the SI. So then you need to convert this coulomb into SI system. That is in ampere seconds. So this per ampere second you can write it. So how you can write it? The work is measured in this unit. You need to divide it by ampere second. So this one divided by ampere second, right? The work make a the work is in this unit, that is kilogram meter square meter minus 2. You divide by the per coulomb, so that is in device ampere second. So the ampere, that's S3 might become S to the minus 3 per ampere. Then you can write this kilogram square meter per ampere per cubic meter, right? I don't have enough space to write that. kg m square a minus 1 s minus 3. දිගට ලියන්න පල්ලෙහාට දාලා ලියන්න. සාමාන්‍යයෙන් පොඩි ඉතකලා ලියන්න. kilogram m square a minus 1 s minus 3 a minus 1. එහෙම ලියන්න. This one is also, you can write like this. Make up from me. So this volts is in this units and for another ampere gram. So then kilogram square meter per cubic seconds and per square ampere. kg m square is minus 3, is minus 2. A minus 2. electrical capacitance then the last one. Make a makalali like square a square s to the 4 kg minus 1 m minus 2. Potential like a coulomb multi included, so you try it like this. Hurry. The Kiturudi Garians in 11 on the mom, 80. And the variety Makana. All right. The other one, the 11th one, then magnetic flux density. Magnetic flux density. Magnetic flux density, right? So it's measured in Tesla. The symbol capital T. Definition is that magnetic flux divided by the area. Magnetic flux divided by the area. And here you need to know that the magnetic flux is measured with the different, the special name for given, that's the Weber. Special one, right? Weber is WB. Weber per square meter. If you don't know this WB, WB is called the Weber. All right, here the WB is the Weber. The unit is Weber. Weber per square meter. We send in kilogram. Is minus 2. A minus 2. That's how we write in SI unit system. It's minus 2, so A minus 1 ampere. That's 5 ampere. Yes. That is Tesla. Another one is luminous flux. Luminous flux. Luminous flux, that's about the light intensity. So it is called the lumen. That is LM we use. Simple length, right? Lumen. Its definition is that luminous intensity multiplied by the solid angle. Luminous intensity multiplied by the solid angle. And multiplied by the solid angle. The luminous intensity measured in candela. Solid angle is stray radian. So it is candela stray radian. CDSR. Don't worry about the base unit is same as this, right? The CD stray radian. The next one, entropy. Entropy, or we call it thermal capacity. Thermal capacity. Right, entropy or thermal capacity. Uh, Special name of the unit. So actually they don't have the special symbol. So from here, I'm not going to write this one, right? Then in possible table it's only this name you consider, right? And also you don't worry about this expression. That's an equation because those are related to the thermal physics part. So different definitions there. We have common method it's boring, right? So we are not going to try this in only the SI units and base units we write there. මෙතනින් පස්සේ කමන්න මෙහෙම වෙයි. ටේබල් එක අපි හතරකට වෙන් කරගමු. එතනින් පස්සේ නැත්තම් උකලන්න. එතනින් පස්සේ ඔය ටේබල් එක ක්ලෝස් කරන්න. So close the table and we'll do the another table for different physical quantities which use in thermal physics. මේවේ තව units තියෙනවා. ඒවා මේ ටේබල් එකත් එක්ක දෙන්න. මේ බේසික් අවශ්‍යම ටික තමයි ඔයාලා යන්නේ සිලබස් එක කියලා දෙන්න. ඒක නම් තියෙනවා. With the table එක වෙනම ආයෙ ලියාගමු මෙහෙම. So the first column is quantity. When you worry about the definition, the name of SI unit, name of SI units, and then the symbol, and using base units. So it's SI base unit. Name of column. Back විතරක් දාන්න. ඉතින් පස්සේ ලියන ටික එහෙම විතරක් දාන්න. හරි. මේවා මතක තියෙන්න ඕනේ එකපාර එකයි විභාගෙ ලියන්න. හරි. ඒවා හැබැයි එක එක පාඩම් ඉස්සරහට එනකොට අර නිකම් automatically you can keep in mind. උඩ තියෙන ටේබල් එක ඉවර කරලා කියන්න යටින්. Okay, then one by one again, right? That's entropy or thermal capacity. Entropy or thermal capacity. So its name is joules per Kelvin. Writing is joules per Kelvin. So that's JK minus 1. In SI base unit, joules you can write as kilogram, like that's a SI base unit that you can write is meter square, kilogram, S minus 1, S minus 2, K minus 1. That the second one, thermal conductivity. Thermal conductivity. So its unit is joules per watts per meter per Kelvin. Watt per meter per Kelvin. Watts per meter per Kelvin. That symbol is that's watts W and meter per meter M minus 1 per Kelvin is K minus 1. Size system we can that's the base units meter kilogram is minus 3 meter kilogram minus 3 K minus 1. This K is capital, right? K should be right in capital. The third one is permeability. Don't worry about this name. Permeability is related to the magnetic fields, properties in the medium. That's permeability. So Henry per meter, its unit is Henry per meter. The Henry is right in capital H. That's the units of measuring the conduct. That's we call it the induction. H per meter. And then SI base units we can write is meter kilogram is minus 2 A minus 2. Another term is similar to this is called the permittivity. Permittivity. Permittivity is the newtons per meter. Sorry, it's a farad per meter. Farad per meter. Is F minus 1. So it's in SI base units. This ampere square is to the 4 kg minus 1 and m minus 3 per cubic meter per kilogram per cubic meter. This මෙයා අන්තිමට තියෙන පාඩම් වල එනවා හරි පුරම surface tension especially newtons per meter newton per meter right is kilogram is minus 2 kg is minus 2. The moment of a force moment of force. This we call the force torque. You can say it's a core torque, moment of force. The Newton meter. Its definition is easy actually. It's force multiplied by the perpendicular distance. So that's Newton meter. This is a unit system. You can write square meter kilogram per square. This is similar to the energy. Book unit energy unit equal. Seventh. For the electric field intensity. Electric field intensity. Measured in volt per meter. Volt minus V minus 1 volt per meter. This meter kilogram minus 2 A minus 1. Into kilogram. It's minus 3 A minus 1. Definitions so then you can write this. But initially I'm given this all, but may I may based on some young man. Just take a makala peat vasilium. Send a young lamatikiano. Another 3 units we had, right? Okay. Other 3 also I'm writing. Eighth on electric flux density. Electric flux density. Right. So it's measured in coulombs per square meter. Coulomb per square meter. The C m minus 2. So m to the minus 2. So the coulomb you can write as ampere second. And it's ampere second m minus 2. Ninth on specific entropy or specific heat capacity. Specific entropy we can write is specific heat capacity also. So familiar name is heat capacity. No? Specific heat capacity or specific entropy. Joules per kilogram per Kelvin. Joules per kilogram per Kelvin. That is joules per kilogram per Kelvin. By simplifying joules kilogram cancel. As meter, square meter, S minus 2, Kelvin minus 1. Right. So the final one is also specific entropy. It's similar to this. You don't need to write this. Is within bracket you write this. Specific entropy is also same. Don't write to any different one. That's true. There are more than this also, right? There are so many units in this derived units are there, but these are most common things used in your syllabus, right? These heats related one, this one we use in the heat lesson. Electricity lesson, that's electric field lesson, we use this electric, that's a permittivity and electric field intensity, flux density, like things. In magnetic field, we use that permeability, magnetic flux density, and magnetic flux. So those things we use in the that's magnetic field lesson. And there's a volts, currents, they we use in the electrics lesson. So in mechanics, initially we discussed that thing, we chose in mechanics lesson. And other than this, for the rotational motions, we have the angular velocity, angular displacement, angular speed, angular acceleration, torque, moment of inertia. So different also there. So I'm not mention those things. I will give this complete table with the tutorial and go through it, and then with that lessons we discuss all things again, right? මම මේ හැම පාඩමක්ම කරාදී මේ ඉන හැම එක ඩිරෙක්ට්ලි මේ යුනිට්ස් එක ගැන ආයෙ කියනවා. But if you finish this writing table, close the table and let me know. Then we are going to discuss about the multiple factors, right? The suffixes and prefixes. Sorry, finish. Raise your hand. Then pass me the Monday පාරම overall syllabus to describe about this smallest and the range of the measurements. But it's kind of commonly and the range of the mean that's the smallest distance when you consider about the distance, the smallest distance which can measure that's corresponding to the size of a proton actually. That's proton size is about 10 to the minus 15 meters, right? And largest distance we consider that there is a observable diameter of the universe. It is about 10 to the 27 meters. So we got the masses consider about the masses. The largest mass in this universe is the mass of a galaxy. Its order is about 10 to the 41, right? 10 to the power 41 power, right? The smallest mass we are considering just as a mass of an electron. This is a single unit. The mass of electron we can consider. So it's considered as a 10 to the minus 31 kilogram. That's order only. The actual value is 9.11 into 10 to the minus 31. And when you consider the time also, the smallest time it's measured in this thing is called that's time is taken by the lights to passes through the atomic nucleus. So it's about 10 to the minus 24 seconds, right? That's the largest time interval we consider. That's a lifetime of a normal star. So it's about 10 to the 18 seconds. So these things are the smaller things and given as sizes, and this thing I'll give it as a table just to know about only that. So you don't need to worry about it. You can you don't need to worry. These are the units, right? So then write there the properties of units. Unit එකක් විදිහට පාවිච්චි කරනවා නම් ඒක කියන්නේ some properties there. So right, some properties of units. Unit එකක් නම් it should have a well defined. So definition එකක් තියෙනවා හරියට. So it's well defined. Very defined කරපු එකක් වෙන්නේ. ඒ වගේම so it should be invariant. Invariant means cannot be vary with the time. So that's why they use that in the previously the definition is for the kilogram. 1 kilogram is the definition about that's a mass of a prototype 1 kilogram a block. That's a platinum block. But they changed it in 2019 as their universal constants. They define it with the universal constant because the definition will not hold for longer. Right, the properties of units. Properties of units, right? Properties of units. That's first one, right? The common size. Common size. Okay, then right there, the unit should have a size. The unit should have a size that is most commonly used. That is most commonly used while measuring a physical quantity. Only used while measuring a physical quantity. If a common size is used, if a common size is used, it makes the measurements easy and efficient. It makes the measurement easy and efficient. It tells you, let's say, to measure the length of a room. If we use kilometers, it's not the common size for that, right? So because if we 1 kilometer means it's very large. So then when you are measuring the room, its common size is about meter. It is easy way to handle and it's efficient you to measure. නැත්තම් convert කරන්නයි ඔය කරන්නේ මොකක්ද? But if you use a meter to measure the distance between the stars, so it's not the common size for that. So in that case, we use without this SI unit system, we use that we call it as astronomical units. We use astronomical units AU. AU means 1 AU means that's the average distance between the sun and earth. එතකොට ඒක ගත්තාම අපිට කියන්න බෑ sun ගේ ඉඳන් ගත්තේ let's say that's 100 astronomical units means there are 100 times of distance between the sun and earth. In that right common size එකක්. You can write examples, right? That's meter, 1 meter for length and 1 kilogram for mass. That's my common size. It's 1 second per time. So common size. The second one, this unit should have well defined definition. So well defined. These units have well defined. It's second one, right? Well defined. Under that, right? The unit should be well defined. The unit should be well defined so that it is independent of any other physical quantity. So that it is independent of any other physical quantity. Any other physical quantity. And change in any other and change in any other quantity should not affect the units of measurement. And change in any other quantity should not affect the units of measurement. Should not affect the unit of measurement. අනිත් quantities එක වෙනස් වෙන්න බෑ. So it's a well defined. So it's a well defined, the independent of other thing, right? The third one is that's invariable with time. Should be invariable with time. Time invariable වෙනවා. Time එකත් එක්ක වෙනස් වෙන එකක් වෙන්නත් බෑ. අද තිබ්බ unit එක හෙට වෙද්දි වෙනස් වෙලා නේ. It's not a good one, right? So then the unit should not change with the time. The unit should not change with time. Should not change with the time. So that means the unit of measurement for a physical quantity, should be the same irrespective of time. Should be the same irrespective of time. Irrespective of time. Both under possible to reproduce. Possible to reproduce. 1 meter කියන එක ඕන වෙලාවක ඕන තැනකදී ගන්න reproduce කරන්න පුළුවන්. නැත්තම් ඒ unit එක කාලයක් යනකොට නැති වෙලා යන්න පුළුවන්. So possible to reproduce. Right? The unit of measurement should be fixed. The unit of measurement should be fixed in such a way that it should be easy to reproduce whenever required. The unit of measurement should be fixed in such a way that it should be easy to reproduce whenever required. Okay then. When we are considering about the units, so some units are very large, then some measurements are very small, right? So very large and very small. To express this, we use the prefixes. Prefixes means there is some multiples of power of tens. Prefixes. As example, the 10 to the minus 3. Let's say that you have the measurement like 1.32 into 10 to the minus 3. This 10 to the minus 3, when you write in this and write and read, it's not easy then. So then to 10 to the minus 3, we can write as a prefix is milli. We call it milli. So this is the prefixes, right? So it's called the prefix, right? So then if it is in meter, so you can write it's millimeter. If it is kilogram, you can write the that's we write the not millikilogram, we are not writing, it's on the gram, right? So in seconds, we can write milliseconds like that. Okay. Then you can write a small topic as a multiples and submultiples of SI units. Multiples and submultiples of SI units. Multiples and submultiples of SI units. Under that, right, when presenting physics, when presenting physical measurements, when presenting physical measurements, it is somewhat difficult to express it is somewhat difficult to express and write according to their size, according to their size. Some measurements are very large. Some measurements are very large. Or very small. Very large or very small. Very large or very small. So it is not possible to write or read. It is not possible to write or read as it is. In such a cases, it makes it easier. In such a cases, it makes easier to write multiples of powers of 10, to write multiples of powers of 10 for ease of writing. For ease of writing. Then the multiples taken as powers of 10, the multiples taken as powers of 10 are called prefixes. Are called prefixes. name, the name and the symbols of multiple factors. Name and symbols of multiple factors of several prefixes are given in the following table. Given in the following table. And make a table, then the multiple factor is the first column. Multiple factor. Second is the name of prefix name. Next is the symbol of prefix. Some one will come with the Greek counting. Greek calling count करने Latin Greek calling අපි දැන් ඔයගොල්ලෝ අහලා ඇති by කියන්නේ 2 කියන්නේ try quadra penta hexa ඔය chemistry වල IUPAC nomenclature එකේ කරන්නේ hexa hepta hexa septa octa none decane එවනේ යන්නේ හලෝනේ ඔයගොල්ලෝ අහලා තියෙනවනේ none decane දැන් ඒවා තමයි prefixes වල නම් සමහර ඒවා එන්නේ ඔයගොල්ලෝ දැන් ඒ විදිහට තමයි අපි කැලෙන්ඩරේ හදලා තියෙන්නේ ඔය කැලෙන්ඩර් January February March එන්නේ ඒ වෙලා it's a Greek quotes ලා ඔයගොල්ලන්ගේ එක එක දේවීවරු කුමාරයෝ එක එක අය හරි අන්තිම නම් ටික තියෙන December November October September means actually it should be the Septa කියන්නේ 7 so it should be the 7th month but in our calendar it's not the 7th month it's the 9th month right so how this happen ඉස්සර calendar එකේ තිබ්බේ ඔය වගේ 10යි මාසෙ the old age calendar they having the 10 months only right the Greek ruler was that Julius Caesar ට ඕන වුණා මේ එයාගේ නම කැලෙන්ඩර් ඇතුළට දාගන්න. එයාගේ නම. ඒතකොට එයා ජූලි කියලා දැන්. ඒ කියන්නේ අර මුලින් ඉන්නේ ඔක්කොම ජැනුවරි. ඔහම දෙවිවරු. ඔහම දෙයියොන්ට පස්සේ එයා ජූලියස් සීසර්. ඊට පස්සේ නම් ඔය නැත්තම් ඊට පස්සේ තමයි නම් තිබේ 7 වෙනි මාසේ සෙප්තැම්බර්. 8 වෙනි මාසේ ඔක්තෝබර්. 9 වෙනි මාසේ නොවැම්බර් 10 දෙසැම්බර්. එහෙම තමයි. ඒකලයි කවුන්ටින් යන විදිය. ඒක ජූලියස් සීසර්ස් දැම්ම ජූලිය කියලා. ජූලයි. Right. So after the Julius Caesar, the next ruler was Augustus Caesar. Augustus Caesar also wants to think that the Julius Caesar done. එයා යම ඕගස්ට්. එයා කියන්නේ ජූලියස් සීසර් ළඟින්ම දාන්න ඕනේ ඕගස්ට් කියලා. ඒතකොට මාස දෙක පැන්න පල්ලෙහාට. දැන් ඒකයි සෙප්තැම්බර් 9ට ගිහලා ඔක්තෝබර් 10ට ගිහලා ආර්ටික එහෙම වෙනවා. හොඳම එක කියන්නේ ඒතකොට මාස දාද්දි දින තියෙන ටික ගන්නට මාස වලට ගන්නට බෙදලා යනවා. ඒ කලින් මාස 10 තියෙද්දි ඒතකොට එක මාසයක තිබ්බ දින ගන්න දැන් තියෙනවට වඩා වෙනස් වැඩි. 12ක් තියෙන දැන් 30 ගන්න අඩු වෙලා 31ට අඩු. ඒතකොට හින්ද තමයි ජූලියස් සීසර්ට ඕන වුණේ එයාගේ මාසේ දින අඩු මාසයක් වෙන්න නෙමෙයි. වැඩි මාසයක්. So then his month has 31 days. The Augustus Caesar want the same thing. That's why they are having 31 days, 2 consecutive months. ළඟම තියෙන මාස දෙකක දින 31 ගානේ දෙකක් තියෙන්නේ ජූලි and ඔගස්ට් වල ඒ. කියන්නේ කැලෙන්ඩරේ මේ වෙලාවල් කියන එක මොනවද? රූලට වෙනස් කරන්න පුළුවන්. රටේ ජනාධිපතිතුමා වෙනස් කරන්න පුළුවන්, right? You don't know that in this in I have feel that in our country also they change the time 30 minutes. Time මෙහෙම අපේ ලංකාවේ දෙපාරක් වෙනස් කරලා. ඒ කියන්නේ අපි පොඩි කාලේ දැන් උදේ පාන්දර 5 මාර කියලා ගත්තාම මේ එනේ එළියයි. සෑහෙන එළියයි. ඊට පස්සේ මේ ඒ වෙලාව වෙනස් කරා ඊට පස්සේ. ඒක 6 විදිහට පැය භාගයක් ගත්තා පස්සේ. ඒ එළිය වෙලාව වැඩ කරන්න පුළුවන් වෙලාවෙ කළුවර නෑනේ. ඒක 6 කරා. 5 මාර 6. يعني පැය භාගයක් වෙනස් කරා. කළා දැන් 5 මාර විතර යාන්තම විතර කළුවරක් තියෙනවා. දැන් 6 කියන්නේ හොඳටම එළිය වැඩලා. එහෙම වෙනස් කරා ඒක. එකපාර නේ ඔක දෙපාරක් වෙනස් කරා මම මතක විදියට. මේ ඊට පස්සේ ආයේ පස්සට ගත්ත හරි මොකක් හරි එහෙම එකක් කරලා කොහොම හරි ටයිම් එහෙම වෙනස් කරන්න පුළුවන් රූල් එක. හරි. නිකන් දැනගන්න. Right, well, let's say the factor. So 10 to the 1, 10 factors here, 10 to the 2, 10 to the 3. Then after 10 to the 3, we going with the 3 powers, 3 by 3. 10 to the 6, 10 to the 9, 10 to the 12, 10 to the 15, 10 to the 18. You need to know only up to this point only. That's enough. This 10 to the 1 we call it a deca. That's why I'm telling you that this in December, that is 10th one. So this we call the deca. Deca. So it's simple DA we use. And this one is hecta. Simple, you need to write hecta. So it is simple H. Have you heard about this hecta before? It's kilo. This is mega. Kilo, mega. This giga. This tera. And terapeta. And exa. This kilo is K, mega is M, giga is T, tera is T, beta capital P, and exa is E. These are the symbols used for this. The hecta you have heard, I think that the like can me loku kumburu age mine hectare age the hecta 10 to the 2 means is 100. So the hectare කියලා කියන්නේ යාර 100ක් වෙන්නේ. යාර 100 square area එකකට we call it 1 hectare. Hectare. හරි. දැන් මේ යාල ඔක්කොම positive powers, that's increasing order. Now I'm writing in the negative powers. මේක ඉවරනම කියන්නේ මොකද මට ඒකට මේකේ negative දාන්න යන විතරයි. This positive powers are called the multiples. These negative powers are called the sub multiples. මේ ටික ලියාගන්න. If you finish this, you can raise your hand. right? So then write the sub multiples. I meme table like sub multiples. So then this is minus power 10 to the minus 1, minus 2, minus 3, minus 6, minus 9, minus 12, minus 15, minus 18. Up to minus 18, right? This is a minus power. So it's not the sector because like that's different names you use and also symbols are also different. So it's first one you know that is for deci. In chemistry you use that thing. That's a moles per cubic decimeter. කියලා use කරන්නේ. The cubic decimeter එකක් කියන්නේ. එතකොට 1 decimeter means 10 centimeters. That's equals to the 1 decimeter. Cubic decimeter කියන්නේ 1000 cubic centimeter. That means 1 liter. 1 cubic decimeter means that's 1 liter. So it is simple D we use. That is deci. The name of the deci is simple D. And then the minus to be called centi. You know that is also you know that is centi, right? So give me 1 second, please. Okay, sorry for that. Right, I had a call. Here DC and into minus 2 is called the centi. Okay, right quickly and see you use and this normally you need to know think this in this sub multiples normally we use the simple letters and the multiples we use the capital letters. There's a mega giga, there's also capital letters. That's only the deca and hecta we use simple, but in here it's all are simple. Some Greek letter also we use, right? And if the minus 3 is called milli and minus 6 is called, that is Greek letter we use. So micro is mu. The letter mu we use. You can write it as a u and then this side you can write longer. It's mu. It's called mu, right? Yeah. We like mu. And then the minus is nano, simple in, and this is pico, simple p, and this is femto, that is simple f, and this is atto, simple a, the atto. You can write it's attometers, femtometers. Normally it's femtometer in the size of nucleus. We explain it's the femtometers. And after this also something that is into the minus 21 we call the septa, and into minus 24 we call the yocto. The different names also we use. Okay. Anyway, you can write millimeters, nanometer, and femtometer. That's it. The millisecond. That's microsecond, the picoseconds, the picofarad, centimeters. Only the centi is most commonly we use in meters only, not with the other. Right. So if you finish the writing of this and then write as rules to obey in writing SI units. We will finish this part today and then next week we discuss about the dimensional analysis. And also I will plan to do the extra class for you because last month we had to do only 3 classes only. So I had to complete another class then. So I will send you the message to the group and you answer me what the possible date. I think this holidays you can. The other classes තියෙනවා නම් මම message එකක් දාන්න ඒකට මේ මට available වෙලාවල් ටික කියලා ඒකේ possible වෙලාවල් ටික කියන්න ඕගොල්ලෝ නේද අපේ සතිය ගොඩක් කරලා discourse කරන්න වෙන්නේ online but I will cover another day right හරිනේ මේ ටික ඉවර නම් කියන මට කල rules ටික ලියලා අපි special science ටිකක් තියෙනවා ඒ ටික ලියුවාට පස්සේ units වල පැත්තේ ඉවරයි ඊට පස්සේ අපි dimensions පටන් ගමු හරි so then write there the rules to obey in writing SI units. Small topic, right? Yes. Rules to obey in writing SI units. මම ඔය ගොඩක් ඒවා දැන් කිව්වා ඒ ටික ලියා ගන්න එක තමයි දැන් කරන්නේ. එකක් කිව්වා මේකේ ස්පේස් එකක් තියන්න ඕනේ කියලා කිව්වා. ඊට පස්සේ ඒ prefix එකක් සහ unit එකක් අතර you have to write without any space. එක එකක්. අනිත් එකක් තමයි අර person name එකක් නම් unit එක විදියට එන්නේ capital අකුර ලියන්න ඕනේ. There's only one unit in physics. The person name we use as the unit name, but the first letter of his name is not used as a symbol. That is the units of resistance. That's ohms. The ohm is the name of that person, but we use the letter, the Greek letter omega we used to use as a symbol. Okay, then right there. The first one, right? One by one, right? First one, right? In writing base units, the unit should be written, the units should be written on the right side of the value, and close to it, Example says 20 kilogram. The right is 20 kilogram. Right side is unit. An example is that's 10 meters. That is 10 meter length. First examples you write there. Then second, අනිත් එක තමයි මේ plurals use කරන්නේ. හරි. meters කියලා මේක මේ s අකුරක් එහෙම දාන්නේ නැහැ. හරි. ඒක rule එකක් විදිහට. So write this as a rule. The no plurals are used. No plurals are used in writing SI units. No plurals are used in writing SI units, even if the value is greater than 1. Even if the value is greater than 1. Even if the value is greater than 1. Example right is 7 seconds. The 7 seconds we are writing is 7. Only one is that's all. Seconds only. No plurals are used. 7 seconds. Only one. Right, the third one. The base units දෙකකට වැඩියෙන් use කරනවා. If you ask more than two base units, each base units in between each two base units you need to put a space. අනිවාර්යෙන් gap එකක් තියෙන්න ඕනේ. One space gap එකක් තියෙන්න. Then write there in writing units as a product of base units. As a product of base units, there should be a single gap or space. There should be a single gap or space between base units. Between base units. Between base units. Example, write the 5 meters per second. We write in is equals that's 5 meter per second. There should be the gap between this meter and s. And s per s, right? And next is this 10 kilogram meter per second. This 10 kilogram meter per second. Two gaps. ඔක අපි ලියද්දි එච්චර බලන්නේ හරි රූල් එකට තියෙනවා ලියද්දි එක දිගට ලියනවා ඒක නෑ fourth one, right? Fourth one. In writing the value of a physical quantity, in writing the value of a physical quantity, value of a physical quantity with a prefix, the symbol corresponding to the prefix. In writing the value of a physical quantity with a prefix, the symbol corresponding to the prefix should be written in front of the SI unit. Should be written in front of the SI unit. In front of the SI unit. SI unit symbol again. In front of the SI unit symbol. And there should not be a gap between the two symbols. And there should not be a gap between the two symbols. So examples. Yes. Millisecond. Millisecond. You can write this a millisecond. Nice. So another one, nanometer. Nanometer. This is nanometer. No gap. These rules are given. The reason is that someone can write it as like this and like this, right? So this is meter second. This is millisecond. To identify this difference, that's why you need to put this. මෙහෙම එකට බැඳලා ලිව්වොත් දැන් මිලිසෙකන්ඩ් කියලා ලියන එකත් කාර මීටර් සෙකන්ඩ් කියලා යුනිට් එකක් වෙන තැනකදී so මීටර් සෙකන්ඩ් කියන එක මිලිසෙකන්ඩ් විදිහට කියවන්න පුළුවන්. ගොඩක් ඒවා එහෙම වෙනවා. දැන් මීටර් කෙල්වින් කියලා එනවා. මීටර් කෙල්වින්. රැක මිලි කෙල්වින් කියලා. හරි. ඊට කෙල්වින් කියන එක ඊළඟ දැන් Kelvin කියන එක දැන් අපි දන්න we know that in temperature you are familiar to measure in Celsius. Celsius degree. Fahrenheit degree. So when you write in this degree, you mention the small dot or small zero you need to write above it, right? But in the case of Kelvin you don't need to put this zero there because we are not calling that Kelvin degree. We call it directly Kelvin. Right? So that's you need to keep in for a degree. We can degree what Kelvin no the දාන්නේ නැහැ zero. Right? ඒකත් then the finally right the fifth one. In writing temperature in Kelvin, Kelvin is scale කියලා මම writing temperature in Kelvin is scale. No need to put a small zero. No need to put a small zero to indicate degree. Example 298 Kelvin. We can write it as 298 capital K1. All right. Okay, then write the next rule. There. Sixth one, right? The name of a unit should be written. Name of a unit should be written in lowercase on in English, right? English in English lowercase. So simple letters you need to use. The name of a unit should be written in lowercase characters. In lowercase character. Let's examples. Newton, joule, and that's a kilogram, meter per second. This all should be in simple letters, only the lowercase. That's the name of the unit. For make a Newton mehamali, it's wrong. It's the name of the person. This is the name of the unit. So then let's say if I given in a simple letters, or then you can identify it's not the name, it's the unit. Seventh right there. Seventh rule. Okay, seventh rule, right? If the name of a unit is a name of a unit is a name of a person, if the name of a unit is a name of a person, the comma, the first uppercase character, or English, capital English within bracket, right? The capital in English, the first uppercase character of his or her name, of his or her name is used as the unit symbol. Is used as a unit symbol. The second letter එකක් use කරන වෙලාවක ඒක simple වෙන්න ඕනේ. එකක් උඩන් යන්නේ. If the second letter is used, it should be simple. Examples. There are so many. I'm writing this one only. This is a unit of force. This is unit of energy. This is unit of power. This unit of current. Unit of pressure. There are many, so write as examples. I only. There's a Henry, Coulomb, Farad. What's we are writing already? That's Kelvin and Weber. After you writing this at the put this right there, but the unit of resistance, is ohm. Unit of resistance is ohm. Is OHM. Is ohm. Which is the person name of person. Okay. and its unit symbol is omega, the Greek letter. Its unit symbol is omega. Okay, there is only one in physics which not obeys this rule. Take example like this, it's only one. Okay, there are some special units because the kilowatt hour electron volts. I'll give those in next week. I think you also feel hungry. I also feel hungry. Right? So that's it. So I'll stop the class from this point today. If you have any question, you can ask now or later, or if you have, you can switch on the mic and ask. No questions. Even I miking under the chat type can run chatting. During the class, anytime you can ask question. I think you have to do the online classes 2-3 days because of this petrol problem. It's not seems to be solved within 2-3 weeks. One හිතනවා දැන් ඔයාලට මම දැන් ගෙවල් වලටත් right ඒක දැල්ල ඉඳන් එන්නත් පෙට්‍රල් නැති තත්ත්වයක් තමයි තියෙන්නේ නේද? ඩීසල් පෙට්‍රල් පුත් නැහැ. පයින් එන දොර නම් එන්න පුළුවන් නමුත් එහින් එන්න බෑ. පයින් නම් එන්නේ මේ අපි ඉස්කෝලේ යන්නේ නැද්ද මම ඉස්කෝලේට නම් මට මෙතන පොඩි දුරයි දෙන්නේ. ඉස්කෝලේත් ඔන්ලයින් කරන්න කියලා දාලා තියෙන මේ දවස්වල. ඒ හින්දා මේ අපි බලමු ප්‍රශ්න විසඳෙනකම් පුළුවන් විදිහකට මොනවා හරි කරමු නේද? තමයි කරන්න දෙයක්වත් නැහැ. Right, in next week we'll meet. Before that, I will send you the message to the group, and if you ask me, we'll assign a extra date cover up another day, right? While family and Uday were working, the run to Lana Honda. Mum, I make a care and done now, or will we take a key under go? Just 2 hours session. It was a dimensional analysis. Next one. Up to now, you need to keep those in mind actually, right? I'll give you the, I'll send you the PDF, and then the physical class is started. I will give the hard copy of that. First, I will send you the PDF copy and also scan copy. PDF cover. Can make me over if something missing or something missed, I'll take a thicker gamma. Question to take it possible. Fine. Hare na zero answer nahi hai modo. God bless. Happy you can leave. You finish all if you